Well, it's good to be back again. It's good to see all of you, and it's exciting. We've had quite an ICS detection challenge, and we're here to report on the results of the second day of the contest and who the overall winner is. So we've been excited to find out who was going to win, and I think you probably all are too. Just to give you a quick what we're going to cover today or in the next half hour. We're going to do a recap for those of you who weren't here on Tuesday to hear about day one. And then we're going to talk, what you really want to know is how the contestants performed today and what we learned in doing these tests.
So why did we do this? So I don't like to sleep. Erik doesn't sleep. Anyone in this industry pretty much doesn't like to sleep. We were really curious about the state of DPI and ICS, given that our background is indeed in this. And we really wanted to validate the vendor's product claims against, what's actually out there against real traffic. And it's really hard to get real traffic. And we really wanted to learn what is possible today with the vendors that volunteered.
So just to give you guys a recap on what happened in day one, the idea is we were playing a very large PCAP collected from about 15 different real live sites. Ron will talk more about that in a second. And what we asked them to do was to identify as many assets and details, but no anomalies. We weren't looking for anomalies on day one. And we gave a day one winner. We were basing the scoringness on their completeness of their ability to identify assets and fill in details. And they got some extra credit for unique findings.
So day two was today. It was all about detection of any events or behaviors. We'll avoid the term anomaly. The PCAP stream was very similar to the base for day one. It was almost the same, except we changed a lot of the streams, so that there was no real asset changes. There were some, but no real ones. And it was modified to introduce malicious and surprising traffic. And malicious is kind of like attacks or hacks, but surprising is stuff that you wouldn't normally see, edge cases, or maybe a new device was brought online. And the objective is to detect, identify unusual behavior. So a new device maybe changes its lifetime goals, and it wants to be chief for one day. So that was kind of the goal for the vendors.
And I might add on that, unusual behavior wouldn't necessarily be malicious behavior. It could be misconfigurations. It could be just devices failing. We wanted to see what they would do. It would be unusual in any way, not just evil, although we like to call it evil.
Yeah.
The most important part of this whole contest are the contestants, and we really want to thank Claroty, Security Matters, and Nozomi and Gravwell for stepping up to the plate here, because this was a tough contest. It was tougher than the real world, much tougher than the real world, because while these were real PCAPs from real facilities, they didn't have the ability to do long-term baselines. We really only had an hour of traffic for them. They had no context. We didn't give them any information like what equipment, what the primary vendors were. They had to figure out all that. Of course, in a real site, you'll know whether it's a Honeywell or an Inventus or whoever it is, but these poor guys were just stuck out there with a PCAP. So no context, and also they were only getting a view of what was effectively one sensor. In effect, it was samples from 15 different places, but all played through the same port. So that also gave them a lack of sort of physical orientation. So this was tough.
Yeah. So the base traffic, like I kind of mentioned, 15 locations across the oil and gas midstream locations. So we have control centers, multiple stations, terminals. There's approximately 15 million packets sent in 1 hour, on average 6.5 megabit per second. There was over 800 IP addresses in the consolidated stream. It was composed of SCADA systems, PLCs, protocol converters or gateways, VFDs, flow computers, and HMIs and a bunch of other things such as vendor laptops. So we kind of described what evil is. Evil is just anything we added, more or less, but not necessarily. And we classified that into 10 different categories. We went from penetration to command and control, or CC, internal reconnaissance, it could be external too, lateral movement, so if one host is infected, what happens? Does it go to another host inside? Does the evil then replicate elsewhere? obfuscation or hiding, so making something look like it isn't. Denial of services, process modifications, logic modifications. So logic is the programs on the PLCs or anything that's doing the automation. Policy violations, did X machine talk to something else, did something wasn't supposed to, so Bob logged into a different machine or Sue accessed a different type of file. And then we have self-inflicted user error. So these are misconfigurations, these are the wrong port switch,
We had one where we had samples of a card being removed, a live card being removed out of a rack. And so all sorts of little things that would be real life. And we wanted to make this as real life because it's not all just the bad guys. We can do a lot of damage to ourselves.
And there was one case where clients are looking for a DHCP server, but there is no DHCP server. So you've those kind of things that are really important as side benefits of looking for security.
Yeah. Okay.
So this is my game. So then we added the bad and strange stuff. So we added the malware. We actually added malware for Havix, Stuxnet. We actually did lateral movement with Stuxnet. So we went from an infected host in the DMZ, a very important one, to an interior location, which then had access to more things on the plant floor. We did port scans, so the obvious stuff. We did a very fast and greedy script kiddie-like scan, and then we did a few slower ones in between to see if they would kind of get the behaviors. We did policy violations, so some organizations, they shouldn't allow clear text passwords being set. Well, there were some of those. There was accesses for printing in certain places that maybe shouldn't have been. We had logic changes, and some of these were not ours. These are actual real logic changes on the floor. So we're dealing with some of that. Different firmware installs. There could have been hidden process changes in Modbus. So there's some edge cases, or what I like to call interpretation by implementation, or we can go back and forth on those words, but little secrets in there when the spec isn't quite so clear. And I want to say that we also shoved in some buffer overflow attacks against one particular PLC. And I think there's something interesting to be said about that, but we'll talk a little more about that later.
Okay. So at this point, we want to tell you about the results. And just before I do that, I'm going to invite one of the other primary judges, John Cusimano, out to join us. John ran day one, and he was sort of really critical to the whole success and survival of the team, I think, in day one. So let's get into what happened in day two. Okay. So we learned a few things. This is not just about us collecting good packets and injecting bad ones and playing them at some poor guys. We were actually wanting to learn and see where the state of the art was. And honestly, the technology exceeded our expectations. The level of reporting was better than we expected for this product category. I'd also say that the other thing that really struck us is we would be looking through the reports or the results, and we'd be on one of the contestants, and we'd go, wow, is that ever cool? They're really good at this. And then we'd be on another one, and they'd be really good at something else, but they missed what the first one did. And it turns out that every one of these products has their sweet spot, and they all were very close in their scores. Really, when you look at the scores, there's not a lot of difference at this point. One of the things that we found that all of them did well, and particularly interesting, was this isn't an IDS. This is really good for looking into the issues that we forget about on the plant floor, the configuration issues like, well, Ron mentioned plain text passwords, certificates that are about to expire or have expired and people are just overwriting, or there was all sorts of little configuration issues that if you had a really big team and you're always running around checking every workstation in the plant, well, you'd catch them. But I was quite surprised the number of reports that these tools generated off the real traffic. Never mind the stuff we generated, but just the surprises. You saw the same thing.
Right, yeah.
You know the facility. What was in there was really cool to see how much useful configuration, policy violation, and again, never mind what the bad guys were doing.
So what we think could be improved, and that's what I was going to come back to, is indicators of a problem where, let's say, symptoms. When you have a cold, we have a cough. We might have a fever. Is it a cold? We don't know. Is it a flu? We don't know. So those kind of diagnoses are really missing about an attack. So we could say they saw these exploits, or things that look like what appears to be a pattern, but did an actual attack take place? Something comprehensive that you could go to your manager or your senior execs and say, look, we had a Stuxnet attack. If I go and tell my boss, we found these 3 symptoms of a problem, it's not going to fly so well.
Yeah.
They're going to say, what is the action plan? I want to know about this thing. What can we do? And then but the other thing is the results that we provided. So we didn't touch the UI. We wanted to stay as objective as possible without, introducing I like blue, Erik likes green, none of those kind of problems. But we still require subject matter experts and analysis. So we were given events, and we still needed to go through them to say, oh, that actually is true. Or maybe that a human actually rewrote what was given back to them as an event. And so, that leads a lot of interpretation. I think there could be a lot of improvement there to help everybody in general in this industry. And then we had common domain secrets that were missed. And so Erik's going to talk about one that he found about 10 years ago, and it's open domain.
Yeah, for example, one of the things that we injected were passwords in ICS protocols, in this case, Modbus Schneider. I mean, this isn't a secret. I think this is, I published this one over a decade ago. And we thought everybody would be using it and finding that we were having the word password as passwords in the Schneider protocols. So we were a little surprised that in the actual ICS protocols, there could be more sort of analysis. Some of them, again, you'll see in a second, some were stronger than others in this area. But overall, this is a little bit nitpicky, but definitely there's sort of domain secrets for ICS that still need to get integrated into some of these tools. That said, one of the things is, maybe it would have been better if we were actually sitting in front of the console. As Ron said, the way we demanded results to be fed to us also made correlation difficult. So there was a couple of differentiators that really stood out here. First of all, I was really impressed with Gravwell and their ability to find our really weird Modbus tricks. Ron and I think we know Modbus pretty well, and we know where the bodies are buried. And we put a lot of nasty stuff in there, and Gravwell nailed it. And best as we could tell from the results, they were the only people who really saw into the games we play in Modbus to bury and hide and obfuscate stuff. Nozomi was really impressive. The context on asset behaviors and the context around assets was really, really cool. Like right out of the gate, and I mentioned this on Tuesday, their ability to classify the Telvent equipment and then correlate what Telvent equipment was doing what and how that worked was very, how this anomaly that we were detecting was related to Telvent, for example, was very, very useful. Yeah. So it wasn't just workstation such and such is doing this behavior. It was this Telvent station, which shouldn't be doing this, is doing this.
Yeah, and we had a PLC that was in both the baseline on day 1 and day 2 that was acting a particular way, and all of a sudden it decides to go contact another PLC elsewhere. This is one of their strengths, and it was really impressive.
Yeah. Interestingly enough, Security Matters really gave us great context on the security issues. As Ron said, we stuffed Havix and Stuxnet, and we injected lateral movements of Stuxnet. We injected penetration of Stuxnet. We had lots and lots of bits and pieces, and it was really impressive to watch Security Matters give you a lot of context. Not just say that there's a port scan going on or that there's there's a CVE, but actually some context around that, and that was really good. And lastly, Claroty really showed some product knowledge of the 2 PLCs in the environment, one being Rockwell and the other one Schneider. And that showed in their reports and the depth of their reports. So you remember from day 1 that Claroty won by just a nose over Security Matters and Nozomi, who were tied. Gravwell put on a very, very valiant effort, very, very strong performance. But again, it was Claroty in day 1. So what about day 2? What was the results for day 2? Well, in day 2, you can see that it's a repeat of day one, really. You can see our different categories that we had run and talked about how we categorize things out. And you can see that Claroty takes it with 24 for day two. Security Matters takes 22, tied directly with Nozomi one more time. And then Gravwell valiantly hanging on there in fourth. And so what about the overall winner? Well, I'm proud to and happy to introduce the winner. And of course, it is Team Claroty, Amir, Tal, and Nadav. Let's have them out. Give them a big hand. Hey, Ron.
Hey.
You guys have the seats. Thanks. So we'll let these guys have the seats and really tell you what they learned and what their thoughts. And this will really be a chance for them to, they've just been nose down on their machines now for 3 days, and we're letting them out for the first time, I think. Whoops, jumped the gun. So, yeah, whatever you guys want to say. Tell us about your experience.
First of all, thank you for the challenge. It was very interesting for us it's like any challenge, we're coming from the research team, we're part of it. We have a team back in our main office in Israel, where we conduct all of our development of the product and research of the protocols. The people that you see here are part of the people that actually work on the PLCs, the setup, see the bytes, look for the detail that we actually found in the pickups. For us, it was like everyday research, taking unknown data, leverage what we actually know, and look for the differentiate traffic on the wire, leveraging all the knowledge we have based on the protocol and information we have. You can see it in the results, the fact that on a daily basis, we deal with understanding the way that devices work on the network, what's normal, what's abnormal, and just collect all the data and try to put it into a normalized baseline. So for us, having this challenge, and again, with the sophisticated attack vector, which actually shows the real-life scenarios, you have composed together an actual scenario which might happen and actually happen. I think it even integrates WannaCry, for example, with the external exploit going all the way until unsecure protocol or legacy protocol for fully proprietary, unknown to a lot of other products in the market. For us, it was very interesting finding the hops, finding all the other anomalies in the existing network. Again, very interesting. We enjoyed it. It was very challenging, very tight pressured. Took everything in order to compose and put it into the format and, of course, find all the details in the right time. Thank you for that. I know a lot of effort to do such work, even for us with the experience of installing customer sites, getting that information. It's not an easy job. So thank you again for the challenge team. It was a great chance for us to do so.
Were there any surprises? Anything that you guys just didn't see coming at you that really surprised you or you didn't expect?
Look, first of all, tons of data. Not a small network. Finding anomaly in such a big network. And again, ICS is very challenging. Everyone implements it differently. Looking at the protocol, looking at the fine-tuned numbers. As you said, building a baseline just in 2 hours, not an easy job. Usually it takes weeks in order to understand the baseline and then focus on each one of the system and build the correct baseline. And again, evaluate it, see that it fits, see that the profile is actually something that is correct and is in place. For us, seeing the good and the non-good is quite hard. We have our own correlation on detecting changes based on the protocol and seeing the anomalies, but each one of them taking the category and understanding that was anomalous and dangerous. It's a different thing, putting aside all the known attack, all the lateral movement, the exploit being used, even that, just analyze, understand that that's an exploit, somebody jumping, where you're trying to move, what's the end game? Usually that's a very hard question. So I think even our guys, we talked about the actual, you told us afterwards, we discussed the general attack vector on the exercise. And again, we dive nose in, collecting all the artifacts and seeing the anomalies and building a picture, as you said, takes a bit until you stand, take a step back, look at the entire image and understand actually, oh, that's what he wanted to do. So again, very interesting, very good for us. We understand a lot. And again, I think even the environment in the challenge room, everybody were engaging and trying to find, and I think you hear a lot of technology, and you saw it in the report, and approaches based on the question everyone asked, and the discussions we had. I think it was very good. Our competitors, you can see based on the scoreboards, were very much into it, and I think you touched it. Each one of the product has its own secret sauce, its own angle. I think on how to attack. There's many ways to attack ICS. You need to cover them all. We're in the research team trying, there's a lot of angle. You can research as much as you can. And we're keeping on improving and getting better detection and better focus and anomalous detection on the small details as we can. But I think the products next year will be much more mature based on the challenge you brought in, on the angles you showed us. I guess next year will be very much interesting.
Yeah, I was going to ask. So if we do this again next year, and I can't commit for Dale if he plans to or not, but if we were to do this again next year, is there anything you would suggest to make to improve the challenge and to make sure we're really testing the full capabilities of these products?
Straight answer?
Yeah.
Nope. You need to come up with something. I'm coming with my product, doing my research. I'm not coming to tell you what I want to see. Because in real life, I'm not the one that defines the way that an attacker would choose to take.
All right.
So therefore, the landscape is quite big. You can use the buffer overflow used in the HTTP server, or you can use just change configuration and run whatever you want on the controller. Some will allow you. So
Yeah, that's actually a good point. We're using the buffer overflow, and I think this was missing from all of the solutions is you can detect an attack, but no one ever looked to see if I killed it or not. So yeah, you saw the payload go there, you raised an event, but did anyone check to see if it was still alive and had a heartbeat afterwards? And I think that's something everyone should be doing right now.
Yeah.
Did you see it after a fact that you saw something? And is it behaving normal after something happened to it?
And we can promise you that controller was not behaving normal after Ron had finished with
No,
it.
that went back to the factory DOA for my little fun.
Yeah.
I think it was hard to notice the consequences of each attack. We saw the small events that you used, the exploits you used, and then the configuration downloads and everything. But it was hard for us in this period of time to as Jumbo said, to take a step back and check out the whole picture and see that the controller was not responding after the attack, and see that the whole attack flow was going in through the IT network and then proceeding to the OT network.
Yeah, it's a bit of an interesting thing that where Erik and I walked into this, we almost were in the same situation that you guys were. We were given very little information about it, just big PCAPs. And so we actually had to put it all together for you guys without actually any tools. We did it with our heads down. We figured it all out, figured out where the teleports are, and put it all together for you guys. So I'm really happy that you guys really enjoyed it, and everyone found most of the things we were looking for, but there was also a lot of stuff that was under the hood.
Yeah. And you know, this is one of the things that I was really impressed, because Ron and I had a month or two to look at this. You guys, we fed you with a fire hose. You know, we gave you 15 million packets in an hour and said, find them all and figure them out. So I was pretty impressed.
Again, I think one point, as you said, we call it the activity of the actual assets being down or raising the bar and frequency. I think, you know, that's a different kind of analytic. In this challenge, we based it on detection of alerts. Maybe something more continuous. Maybe one thing to take for next year is to make it a bit longer.
Yeah.
Let's put something that's time pressure, and then let's put something continuous. Because usually when you have attack, somebody comes in, goes back home, comes in with a better thing.
Yeah.
So an attack, usually it's not just target and hit. It's something that continues and puts its artifact in the network, and sometimes even gets into the actual baseline of the network. So it will be interesting to do that as well.
Yeah, that's a great idea. Yeah. Well,
we'll have a whole another year this time to prepare.
Yeah.
So we'll be creative in the next year, and I think the question that I asked you guys probably goes to the audience as well. Like, if anybody has, and I'm sure there are, opinions about how to improve this challenge, I guess I'm speaking on behalf of Dale, but I guess send in your comments and suggestions for improvement. I'm sure Dale will funnel them all to us, and I'm hoping that we will repeat this next year.
Yes. And we'd also, I think, next year really like to organize an open source team. If somebody wants to try and put a team of 3 together that just works on the open source tools. There was a lot of chaos in getting everything and pressure to get everything organized for a very first So I know some of you wanted to, and it didn't quite work out. But yeah, so maybe a open source team would be really cool to see. And the last thing I'm going to ask from all of you is, if you have the ability to donate PCAPs that we heavily, heavily sanitize, because obviously we don't want to use the same PCAPs again. We want to have a new set with a new environment, maybe with a bigger DCS and less of a SCADA feel. And so if you think your company might be willing to donate PCAPs to be heavily, heavily sanitized, and the bonus out of it, besides helping this whole industry, is that we were able to give a fair amount of information back to the company that donated these PCAPs that they didn't know. It wasn't just what Ron and I stuffed in there that was worth paying attention to. There was enough information in there that it made it. So I think it's a real win-win. So I hope that people, you out in the audience, can consider donating a large PCAP set or helping us collect a large PCAP set for next year.
And if you want to know the anonymization process, you can refer to my talk from yesterday.
Yep. All right. Well, thank you very much, and congratulations.
Thank
Another
you,
hand.
guys.
Thank you.
And I'd like to thank all the participants. It was so close, and as I said, everybody had real strengths, so big round of applause for all the participants. Yep.